So let's say that you didn't really get the factoring binomials lesson, because what most people didn't understand is that it really does matter what goes in the boxes, and it really does matter what goes on the outside. And what I probably should have done is made some mistakes so that people could see what happens when you make a mistake and how to fix it. I want you to notice what is the difference between this expression and this expression. In this binomial, there's an x next to the 9, and in this binomial, there's not. And that's important. When we first started talking about quadratic functions, we talked about the fact that standard form is written as ax squared plus bx plus c. A is the number in front of x squared. So 4 is a in this case because it's in front of x squared, and 4 is a in this case as well. So we're going to call this first term the a term. And that term always goes in the upper left-hand corner. B is the number in front of x. This has a b term because 9 is b. Do you see a number in front of just a plain x here? Not an x squared, but just a plain x? No, you don't. So what that means is this is actually 4x squared plus 0b, I'm kidding, plus 0x minus 9. We don't write the 0x, we just know that there's no b term for this. Now the b terms get written, split up between these two squares in the area model. The negative 9x, I am not going to split up between these two. I'm going to put 0 here, and I'm going to put negative 9x here. There's no reason to split it up and make it more complicated if I don't have to. And then finally, you have the c term, which is at the end. It doesn't have an x next to it. So this expression here, this binomial, has an a term and a b term, but no c term, which means that c is 0. But in this case, this negative 9, this is your c term. 4 was a, b is 0, so I'm not going to put anything in these spots. I could put zeros if I want to. And then negative 9 goes here. And what people didn't understand in our previous videos is that it matters. If it has an x, it goes in the upper right-hand spot. And if it doesn't, and it's the c term, it goes in the lower right-hand spot. So now we need to talk about factoring. Whatever is in the area model has to be equivalent to the expression that you're factoring. And so if I say, okay, well, let's do 4x squared. What times what makes 4x squared? Somebody might say, I think that that is 2x times 2x. Okay, 2x times 2x is indeed 4x squared. And then I might say, well, what multiplies by 2x to go here to make negative 9x? And 2 doesn't evenly divide into 9, so that's not what I want to choose. Instead of choosing 2x and 2x, let's choose something else. We could do x times 4x. And now when I say x times what makes negative 9x, that would be negative 9. That works. And 4x times what makes 0? 4x times 0 makes 0. So now the side lengths of the area model are the factors that are equivalent to this. And because what's inside makes sense with everything that's on the outside, they all multiply together to make these expressions, and that's equivalent to this. I know the factors are correct. So I would have x plus 0 and 4x minus 9. But nobody writes it like that because x plus 0 is really just x. And x is a monomial and doesn't need parentheses. But for the other one, the negative 9 is in a different spot. So let's talk about what to do there. If we did 4x squared, again, and we did 4x times x, then 4x times what would make 0? Well, that'd be 0. And this would be 0. But wait, 0 times 0 is 0. Does that match what we want? No. So let's try something else. Instead of that, Let's try what makes negative 9. We could have 1 and 9, or we could have 3 and 3. So let's say that instead of 4x and x, we chose 2x and 2x. That makes 4x squared. Okay. And then let's say that we chose 1 and 9. So we're going to put a 1 here and a 9 here. And let's say that I wanted to ask you, are we going to make these two terms both positive, both negative, or a mix? Well, if this is negative 9, only a mix of signs is going to multiply to make a negative. So I'm going to try this one negative and this one positive. Let's see how it works out. Does what's inside this area model then make an equivalence to this? 2x times 2x is 4x squared. 2x times negative 1 is negative 2x. 2x times 9 is 18x. And positive 9 times negative 1 is negative 9. So I've got the 4x squared. Yep. I've got the negative 9. Yep. What about these two terms here? What is 18x minus 2x? Isn't that 16x? Is that what I want? No. I need these to add up to 0 so that I don't have a middle term. So clearly negative 1 and 9 are not the option that I want to choose. Don't worry, that's why we have erasers. Let's try instead a negative 3 and a positive 3. Well, if I change those numbers, then what's in here is going to change. 2x times negative 3 is negative 6x. 2x times 3 is positive 6x. 3 times negative 3 is negative 9. Okay, look at your terms here. What is 6x minus 6x? Isn't that 0x? Is that what you want? Yes, it is. So since I know that these combine together to make this expression, I know that the numbers that I chose on the outside are equivalent in factored form to what I originally started with in standard form. One more. Let's apply this to trinomial. This is your A term. This is always going to go in the upper right-hand corner. This is your C term. This is always going to go in your lower right-hand corner. Did I say right? I meant upper left. And then your B term is going to be split up between here, but we don't know how. This is the puzzle we have to figure out. So let's start with 2x times x makes 2x squared. That one's easy because I really don't have any choices for that one. But as for negative 27, I could do 1 and 27, or I could do 3 times 9. Let's say that I chose 1 and 27. 1